Hello, and welcome to another video. In this lesson, we're going to take a look at Python test frameworks pytest and unittest. Whether you're a newbie or a seasoned developer, understanding these frameworks will help you write better and more reliable Python code. Let's get started. Test frameworks are tools that help developers automate the testing process. They provide a structure for writing test cases, running tests, reporting results, and managing dependencies. In Python, unittest and pytest are two of the most popular frameworks used today. They help ensure your code behaves as expected before it hits production, catching bugs and issues early in the development cycle. A data-driven framework focuses on separating the test data from the actual test case logic. It allows you to store test data, like input values and expected values, in an external database or files like Excel, CSV, XML, or JSON. The main advantage is that the same test scenario can be run multiple times with different sets of data. In a keyword-driven framework, test automation is achieved by using keywords, which are abstract representations of a set of actions, like click and input, that are performed on the application. These keywords and the associated data are stored in external files or tables, and the test scripts read these keywords to execute actions on the application. A hybrid test framework is a combination of keyword and data-driven frameworks. This type provides the benefit of both frameworks and allows for more flexible and powerful testing scripts that can be easily expanded. In a linear testing framework, testers record each step, like clicks and input, as they navigate through the application, and the tool automatically generates the script. This is the simplest form of automation testing, but is generally less flexible and more brittle. A modular framework breaks down the application under test into logical and isolated modules. For each module, separate and independent tests are created. Once the modules are tested individually, they are integrated to ensure smooth system functioning. This approach enhances test maintainability and reduces duplication of efforts. In this course, we will focus on building a modular framework using pytest and unittest. In this course, we will focus on building a modular framework using unittest. Unittest is a built-in Python module that you can use to create and run tests. It's based on the XUnit architecture, which is a part of many other testing frameworks in different programming languages. It supports test automation, sharing of setup and shutdown code for tests, aggregation of tests into collections, and independence of the tests from the reporting framework. Test fixtures refer to the setup, teardown, and cleanup actions that need to take place before and after tests. For example, setup is used to create any objects or state that the tests depend on, while teardown frees up any resources initialized by setup. Test assertions are used to check for specific conditions during the test. Test suites are collections of test cases organized around a testing procedure. Unittest allows different test cases to be executed together. The test runner is a component that orchestrates the execution of tests and provides the outcome to the user. A basic runner outputs human-readable reports in text, but can be customized or replaced. Let's write a simple script using unittest. For the purposes of this demonstration, I'm using Visual Studio Code, and I already have Python installed on my system. First, import the unittest library. Then, define a class named testStringMethods, and remember to subclass with unittest.testCase. Each method in our test class begins with the word test, a naming convention that informs the test runner which methods in the class represent tests. In the first method, testUpper, we use the assertEqual method and pass it two strings. The first string is the string we want to test, while the second string serves as our basis for comparison. We use the upper method in conjunction with the dot operator to make the characters in our first string all capitals. The assertEqual method will compare these two strings and return true if they are equal to each other and false if they are not. In the second method, testIsUpper, the methods assert true and assert false are used to check whether a string consists of all capital characters or not. The isUpper method is used in conjunction with the dot operator and returns true if all the characters in the string are capitalized and false otherwise. The assertTrue method will pass if it receives a true Boolean and fail otherwise. The assertFalse method will pass if it receives a false Boolean. The third method, testSplit, checks whether a split operation fails when the separator is not a string. The method assertRaises is used to verify that a specific exception is raised. In this case, we anticipate a possible type error. We run the test script in the terminal of VS Code, but it can also be run in the command line interface. Navigate to the location of your script in your file system and then run the script. First, invoke the Python keyword, identify the module, set the verbosity flag for greater detail in command line reporting, and call the test by its class name and file extension. All three of our tests pass. Let's see if we can get one of our test cases to fail. I'm going to change the strings in the list being passed to assertEquals in the testSplit method. Remember to save your changes and run the example test script. As you can see, we get a failure from the assertEqual method. Our anticipated results don't match our sample string. Let's write another example test script. This one will check the results of a simple arithmetic operation. First, import unittest. Then, define a method called add, which takes two numbers, a and b, and returns their sum. Next, define a class called testAddFunction and have it inherit from unittest.testCase. Let's continue the naming convention we established in the first demonstration by beginning our method names with the word test. The first method, testAddPositiveNumbers, will assert whether two numbers are equal. Inside assertEqual, we call the add method, passing it two numbers. We also pass our expected output from that method into assertEqual. The second method, testAddNegativeNumbers, performs the same test as the first method in our class, but it uses negative numbers. The third method again performs the same test as the previous two methods, but uses a mix of positive and negative numbers. Again, I'm calling the script from the terminal of VS Code using the same command line invocation from the first demonstration. Our tests pass. Now let's see if we can't get one of our tests to fail. Change one of the expected values and rerun the test. As anticipated, we get a failure. Next, I'll modify our string test to demonstrate how setup works. This method is called to prepare the test by allocating any resources necessary to execute the test. It is called immediately before any test methods, and any exception raised by this method will be considered an error rather than a test failure. Setup and teardown methods are automatically used when they are made available in your classes, inheriting from unittest.testCase. Let's define a method called setup. Inside this method, we'll have a string called example equal to a return value from a method in another class called string builder. String builder is a simple class with one method called buildString. It takes a string and returns that string in all caps with a phrase appended to the end. Update your import statement to import string builder, and don't forget to place an init.py file in your directory. In the method named testUpper, pass in our example string and modify the expected value. We have another passing test. That concludes this simple demonstration using unit test. Later demonstrations will be more sophisticated, but I hope these examples illustrate how assertions work. PyTest is a popular testing framework for Python that facilitates simple but scalable test automation. Although it is not part of the standard library, it is widely used for writing and running tests due to its simplicity. It is an easy-to-use, comprehensive feature set. PyTest allows writing simple test methods using standard Python assertion statements for validation. There is no need for boilerplate code, making test creation quick and straightforward. Fixtures in PyTest help set up test environments and aid in sharing test code. They provide a clean way to create setup code that can be reused across multiple test methods, ensuring the test environment is correctly set up before tests run and torn down afterward. PyTest also has a rich ecosystem of plugins that extend its functionality. These plugins can add features like parallel test execution, detailed test reporting, or integration with other tools. Users can also create custom plugins to suit specific testing needs. Test parameterization in pytest allows running the same test with different input values, thereby enhancing test coverage without duplicating test code. This is useful for testing functions with various inputs and expected outcomes. pytest provides powerful assertion introspection, making it easier to understand why a test fails. It can also capture and handle expected exceptions, verifying that code correctly raises errors when it should. pytest automatically discovers test files and functions based on naming conventions, reducing the manual effort required to specify which tests to run. It typically looks for files that start with test or end with test.py. Fixtures can be scoped to function, class, module, or session levels, providing flexibility in resource allocation and management across tests. This helps optimize resource usage and test execution time. pytest integrates seamlessly with continuous integration and continuous development pipelines and enables automated tests to be executed as part of the software development workflow. This ensures code quality and reduces the likelihood of defects in production. pytest generates detailed test reports, including tracebacks for failures, which help in quickly diagnosing issues. It can also be configured to produce various types of output formats suitable for different purposes. pytest can run tests written using other frameworks like unittest, providing a unified interface for running a wide range of tests. By incorporating pytest into a test automation strategy, developers and automation engineers can enhance the efficiency, reliability, and maintainability of their automated test suites, thus ensuring quality software practices. Let's experiment a little with pytest now. We can modify add test function from our previous demonstration to use pytest assert functions. First, remove the import statement. Remove the class declaration and adjust your indentation. Remove the self parameter from all your method definitions. Remove the whole conditional statement. Change the name of the assert methods. Don't forget to use the equal to operator and not the assignment operator. Now let's save the script and run it. As you can see, we have 3 passing tests. Let's try and make a test fail by changing a value in one of our asserts. Save and rerun the test. As you can see, our test output is formatted differently from unittest. Also notice how pytest automatically identifies the test functions without requiring a class structure. It's flexible and easier to get started with, especially for new Python projects. Choosing between unittest and pytest often comes down to personal preference or specific project requirements. If you prefer a more traditional, structured approach, unittest might be for you. For a more modern, plugin-rich, and flexible framework, pytest is often the go-to choice. Unittest stands out as a favored option for writing test scripts in Python due to several key factors that collectively contribute to its widespread adoption and industry acceptance. Unittest is already a part of Python's standard library, so we don't have to worry about installing it. This ensures that the testing framework is readily available, simplifying deployments and reducing external dependencies in Python projects. Unittest follows design principles present in the XUnit family of testing frameworks. This similarity provides a familiar structure for engineers already acquainted with frameworks like JUnit in Java. This consistency makes understanding and adopting the framework easier than pytest. Unittest also boasts a robust and active community of Python developers who have contributed and continue to contribute to the framework's expansion and refinement. This vibrant community support includes a wealth of resources including tutorials, comprehensive documentation, and online forums. Engineers can leverage this extensive knowledge base for guidance and collaborative problem solving whenever the need arises. Unittest is designed to be compatible with various Python versions, accommodating both Python 2 and Python 3. This flexibility is particularly valuable for projects with specific version requirements or those that need to maintain compatibility with older Python versions. Unittest supports features such as test discovery, execution, and result reporting within the Python IDE environment, giving developers and engineers an easier experience using the framework. Moreover, it is compatible with test runners, continuous integration systems, and coverage tools, allowing for a smooth integration of automated tests into the broader development workflow. As an integral component of Python, Unittest benefits from the collective expertise of Python's core development team. This association ensures a high level of stability and reliability, providing developers and engineers with confidence in the accuracy and dependability of their tests. Finally, Unittest is widely embraced by many prominent Python libraries and frameworks, including popular ones like Django and Flask. The extensive adoption of Unittest in the software industry contributes significantly to its credibility and reliability as a testing framework, making it a preferred choice for developers across many Python projects. In conclusion, both Unittest and pytest offer robust solutions for testing in Python, but for the purposes of this course, we will primarily stick to Unittest when demonstrating automated tests. Thank you for watching. In our next lesson, we'll examine how to set up our testing environment and configure the system for testing purposes. If you have questions or need further clarification on any of these tools, leave a comment below. See you in the next video.